Chapter 1. Computer Networking. Computer networking is the interconnection of various computers for the purpose of communication. The communication includes exchange of data, file transfer with the help of computer system, software applications and users. Computer networking can exist between two computers and continue to happen between hundreds and thousands of computers. Two devices are said to be networked when a process in one device is able to exchange information with a process in another device. The computers that are involved in the network that originate, route, and terminate the data are called nodes. The interconnection of computers is accomplished with a combination of cable or wireless media and networking hardware. We will discuss about this later. Creating computer network. Networking two or more computers together requires a basic understanding of computer hardware and software, but once this process is done, it allows you to share resources between the computers. If you have the right equipment, you can network two computers together in just a few moments with minimal effort. In order to create networking between the computers, it is necessary that the computers have access to same network. Network topology. Topology is the schematic description of the arrangement of a network, including its nodes and connecting lines, while a network topology is the arrangement of the various elements, such as nodes of a computer. Topology is the indication of how data flows within a network, regardless of its physical design. Depending upon the type and nature of the connection made, topologies can be of different kinds. Although the study of network topology recognizes 8 basic topologies, however, the most commonly known are star topology. Alternatively referred to as a star network, a star topology is one of the most common network setups where each of the devices and computers on a network connect to a central hub or switch. In this network, all the data transferred or shared first comes to the central hub and then goes to the respective system. Star networks are relatively easy to install and manage, but bottlenecks can occur because all data must pass through the hub. The primary disadvantage of the star topology is that the hub represents a single point of failure, that is, if the central hub fails, all computers connected to that hub would be disconnected. Ring topology. As the name suggests, in ring topology, all devices are connected to one another in the shape of a closed loop to form a ring. In this network connection, each device is connected directly to two other devices, one on either side of it. Ring topologies are relatively expensive and difficult to install, but they offer high bandwidth and can span large distances. The use of ring topology is on the verge of extinction as the topology offers only one path for information flow. Thus, if any link's failure happens amidst the connection, the entire ring connection would fail. Bus topology. In case of bus topology, all the devices are connected to a central cable called the bus or backbone. Bus networks are the simplest way to connect multiple users. The topology uses Ethernet systems to make the connections. Bus networks are relatively inexpensive and easy to install for small networks. The biggest advantage of bus topology is that if one computer fails, it does not affect the other computers. However, the disadvantage is that if the main cable fails, all the other connected computers will die. Tree topology. Tree topology is one of the most common network setups that are similar to a bus topology, and a star topology. Hence is also referred to as star bus topology. A tree topology connects multiple star networks to other star networks, that is, it consists of groups of star-configured workstations connected to a linear bus backbone cable. In a tree topology, if the main cable or trunk between each of the two star topology networks fail, those networks would be unable to communicate with each other. However, computers on the same star topology would still be able to communicate with each other. Hybrid topology. Justifying the name, hybrid networks use a combination of any two or more topologies in such a way that the resulting network does not exhibit one of the standard topologies. For example, a tree network connected to a tree network is still a tree network topology. A hybrid topology is always produced when two different basic network topologies are connected. Networking hardware. As mentioned earlier, networking hardware are important components that are required to create a computer network. Networking hardware includes all computers, peripherals, interface cards, and other equipment needed to perform data processing and communications within the network. Networking hardware includes many components. They are Network Interface Cards, NIC. The Network Interface Card, NIC, provides the physical connection between the network and the computer workstation. Most NICs are internal and they are included in the purchase of most computers. Network interface cards are a major factor in determining the speed and performance of a network. It is a good idea to use the fastest network card available for the type of workstation you are using. Hub. Hub is an unintelligent network device that sends one signal to all of the stations connected to it. All computers' devices are competing for attention because it takes the data that comes into a port and sends it out all the other ports in the hub. Traditionally, hubs are used for star topology networks, but they are often used with other configurations to make it easy to add and remove computers without bringing down the network. Switch. It is a device that splits large networks into small segments, decreasing the number of users sharing the same network resources and bandwidth. It understands when two devices want to talk to each other and gives them a switched connection. Besides, a switch also helps to prevent data collisions and reduces network congestion, increasing network performance. Router. It is a device that connects any number of LANs. It uses standardized protocols to move packets efficiently to their destination. Its main function is to forward data depending on the network address, IP, not the hardware, MAC address. Routers are the only devices that allow you to share a single IP address among multiple network clients. Types of network. One way to categorize the different types of computer network designs is by their scope or scale. It can also be characterized by its physical capacity or its organizational purpose. Use of the network, including user authorization and access rights, differ accordingly. They are LAN, PAN, MAN, WAN, and CAN. LAN. The local area network, LAN, is a network which is designed to operate over a small physical area such as an office, factory, or a group of buildings. It is usually privately owned and links the devices in a single office, building, or campus of up to a few kilometers in size. LAN is widely used to allow resources to be shared between personal computers or workstations. The resources to be shared can be hardware like a printer or software or data. LANs are very widely used in a variety of applications. A common example of a LAN found in many business organizations links a work group of task-related computers, example, accounting and finance PCs, administrative PCs, or engineering workstations. PAN. A personal area network, PAN, is a computer network used for communication among computer devices, including telephone mobile phones and personal digital assistants, in proximity to an individual's body. In other words, it can be defined as a network that is used for communicating among computers and computer devices, including telephones, in close proximity of around a few meters within a room. PAN can be used for communicating between the devices themselves or for connecting to a larger network such as the Internet. PAN can be constructed with cables or be wireless. USB or FireWire technologies link together a wired PAN, while wireless PAN uses Bluetooth or infrared connections. MAN. A metropolitan area network, MAN, is a computer network in which two or more computers or communicating devices or networks that are geographically separated but in same metropolitan city are connected to each other. A MAN is set up for a larger geographical area than a LAN, ranging from several blocks of buildings to entire cities. A MAN might be owned and operated by a single organization, but would be used by many individuals and organizations. This network often acts as a high-speed network to allow sharing of regional resources. WAN. WAN stands for Wide Area Network. As the name suggests, WAN covers a large geographic area such as country, continent, or even whole of the world. A WAN is two or more LANs connected together. Multiple LANs can be connected together using devices such as bridges, routers, or gateways, which enable them to share data. WAN is more suitable for transfer of data from one user to the other, which is not a time-critical application, as large distances involves the propagation delays and problems with variable signal travel times. An airline reservation system is an example of WAN. CAN. A campus area network, corporate area network, or CAN, is a computer network made up of an interconnection of local area networks, LANs, within a limited geographical area. CAN is usually established in university campus to establish a connection among different computer labs, library, registration office, and different academic units. It is smaller than MAN. What is protocol? A protocol is a system of rules that define how data is transmitted over network. In computer terminology, a protocol is usually an agreed upon or standardized method for transmitting data and or establishing communications between different devices. Protocols are established by international or industry-wide organizations. Perhaps the most important computer protocol is OSI, Open Systems Interconnection, a set of guidelines for implementing networking communications between computers. Internet Protocol, IP. The Internet Protocol, IP, is a network layer 3 protocol that contains addressing information and some control information that enables packets to be routed. IP represents the heart of the Internet protocols. IP has two primary responsibilities: providing connectionless, best effort delivery of datagrams through an internet-work and providing fragmentation and reassembly of datagrams to support data links with different maximum transmission unit MTU sizes. Transmission Control Protocol (TCP). The TCP provides reliable transmission of data in an IP environment. TCP offers reliability by providing connection-oriented, end-to-end reliable packet delivery through an inter-network. TCP offers efficient flow control, which means that when sending acknowledgements back to the source, the receiving TCP process indicates the highest sequence number it can receive without overflowing its internal buffers. Hypertext Transfer Protocol. HTTP is the Hypertext Transfer Protocol that controls how web servers and web browsers communicate with each other. HTTP defines how messages are formatted and transmitted and what actions web servers and browsers should take in response to various commands. HTTP is called a stateless protocol because each command is executed independently without any knowledge of the commands that came before it. This is the main reason that it is difficult to implement websites that react intelligently to user input. Beyond the chapter. Inventor of TCP and IP. Robert Elliott Bob Kahn is an American Internet pioneer engineer and computer scientist who, along with Windsurf, invented the Transmission Control Protocol, TCP, and the Internet Protocol, IP, the fundamental communication protocols at the heart of the Internet. Let's summarize. Computer networking is the interconnection of various computers for the purpose of communication. Topology is the schematic description of the arrangement of a network. Most commonly known topologies are star topology, ring topology, bus topology, tree topology, and hybrid topology. Networking hardware are important components that are required to create a computer network. They are NIC, hub, switch, and router. LAN, PAN, MAN, WAN, CAN are the types of network. A protocol is a system of rules that define how data is transmitted over network. Internet protocol is a network layer that contains addressing information and some control information that enables packets to be routed. The TCP provides reliable transmission of data in an IP environment. HTTP is the Hypertext Transfer Protocol that controls how web servers and web browsers communicate with each other.